Hello friends, welcome back to wonderful online platform C Level Physics. My name is Srinivas, known to be BS Rao. I requesting all the audience to please subscribe channel C Level Physics meant for foundation level cbse, icse, igcse, plus 1, plus 2, Neet, IIT, JEE, main and advanced aspirants. Okay. Now today I am going to give some illustrations based on relative velocity concept. Right? Now first one, see here, suppose a boy cycling at 30 degrees north of east. A boy cycling at 30 degrees north of east with 20 kmph. Alright? A boy cycling at 30 degrees north of east with 20 kmph. Right? Now find the velocity of another boy. Find the velocity of another boy who is cycling due north with respect to him. Another boy means with respect to him, previous boy, with respect to him, previous boy appears to move due east. Right? This is what given question. See, a boy cycling at 30 north of east with 20 kmph. Suppose I am taking here directions north, south, east, west. Right? See, this is the top view of the plane. See, north, south, east, west. Right? So based on these directions, now I'm trying to draw a diagram. Right? Now see, a boy cycling at 30 degrees north of east. North of east means, see the direction. North of east means here first quadrant, but angle is taken with east one. Alright? See here, this is what north, here east, right? So north of east, 30 degrees north of east. So north of east means angle is taken with east. So this is what 30 degrees. So this is the direction of motion of first boy. So what is the velocity? 20 kmph. So this is what V1 bar, that is 20 kmph. Right? Now find the velocity of another boy who is cycling due north. Here one more boy also there who is also cycling due north. Due north means like that. See, this is what north. So this is what V2. V2 means velocity of another boy. So what is the direction of motion of another boy? Another boy, that is cycling due north. So this is what velocity of first boy. This is what velocity of second boy. Now the question is, with respect to second boy, the first boy appears to move due east. First boy appears to due east with respect to second boy. Means the relative velocity of first boy with respect to second boy must be due east. So due east means this one. What is the relative velocity of first boy with respect to second boy means V1 2 bar. V1 means velocity of first boy with respect to second boy. That is V1 bar minus V2 bar. That's what relative velocity concept. That is V1 2 bar equal to V1 bar plus or minus V2 bar. Hence subtraction in the sense V1 minus V2, that is V1 plus of minus V2 means simply add minus V2 bar to V1 bar. Now where is V2 bar? This one V2 bar, that is velocity of second bar. Now make it reverse V2, that is this what V minus V2 bar. This V2 bar, this is minus V2 bar. Simply just make it reverse V2 to get minus V2 bar. Now see, V1 bar and minus V2 bar are parent vector. vectors, right? So v1 bar minus v2 bar are the parent vectors. If I take these two as adjacent sides or parallelogram drawn from the same point, now diagonal drawn from the same point gives the resultant. What is the resultant? v1 to bar, relative velocity of first bar with respect to second bar. Okay, so this is what v1 bar, here minus v2 bar. Now parallel to this one, I am taking one side line, right? Parallel to this one, also I am taking one more side line, right? See, this is what parallelogram, right? Okay, so this side is taken parallel to minus v2 bar, this side is taken to parallel to v1 bar. Now see, this is what parallelogram, right? These two parent vectors drawn from one common point. Now a diagonal drawn from the same common point is the result. See, this is the common point from which I am drawing one more diagonal line. So this is what relative velocities means v12 bar, Okay, see, this is what parallelogram, right? v1 bar minus v2 bar. On adding v1 bar and minus v2 bar, we will get v12 bar. See, what is the direction of v12 bar? That is due east from data, right? So this is what relative velocity. v12 bar means relative velocity of first bar with respect to second bar. That must be in the direction of east, right? In the direction of east from data. Now see, this is what minus v2 bar, otherwise v2 bar, unknown quantity. This is what v1 bar, known quantity. So if it is minus v2 bar, this one also minus v2 bar. Now what is the magnitude of minus v2 bar? v2. So this side is v2, unknown. This side is v1, that is known, 20 kmph. Here 30 degrees also there here. Now from this right angle triangle, sin 30 equal to opposite side by hypotenuse. Now what is opposite side? This is what opposite side. These two one and the same. So vector is minus v2 bar. Here also vector is minus v2 bar, but magnitude is v2 So v2, opposite side v2 by hypotenuse 20. Right? Now sin 30 means 1 by 2. That is v2 by 20. v2 equal to 10 kmph. 10 kmph. This is what v2 means, absolute velocity of second boy, right? With respect to himself, first boy appears to move due east, but with respect to ground, what is the actual direction of motion of first boy? That is 30 degrees north of east, right? Okay, that's how one can solve sum. Now let us see one more numerical. In this example, a ship moving along equator at 30 kmph, right? At 30 kmph. A ship moves along equator, right, at 30 kmph, right? A ship moves along equator at 30 kmph. Now a southeastern wind, a southeastern wind blows at 15 kmph. A southeastern wind blows at 15 kmph in a direction making 60 degrees north of east, 60 degrees north of west, See here, a ship moves along equator at 30 kmph, right? Now a southeastern wind blows at 15 kmph in a direction making 60 degrees north of east. What is the velocity of wind blow here? That is 15 kmph. What is the direction of wind blows here? In a direction making 60 degrees north of east. Now the question is find the direction in which a flag flutters a flag on the flag post or flag pole or post. Find the direction in which a flag on the flag pole flutters due to this wind. So this is the question. Now see, again take the direction like that: north, south, east, west. Right? This is the sign convention. General directions: north, south, east, west. Right? Now, what is the direction of motion of ship here? That is due east. Right? Along equator. See, this is what equator. West to east. A line joining west and east. That is what equator for the diameter. Now, what is the direction of motion of ship here? That is along equator, due east, especially due east at 30 kmph. Now see here. This is what east, right? East direction. Here it is north direction. So north to east, right? Now ship moves along equator at 30 kmph. Along equator at 30 kmph, due east. Some text is missing here. A ship moves along equator at 30 kmph, due east, right? So what is the direction of ship here? Due east. What is the speed of ship here? 30 kmph. So this is what velocity of ship. That is, what is the value? 30 kmph. 30 kmph. Right? Now, a wind blows in a direction which is making 60 degrees north of west. See, north, this is what west, right? West. North, south, east, west. Now, wind blows at 60 degrees north of west. What is the direction here? The southeastern wind. See, southeastern from this side, from this side, wind blows such that making an angle 60 north of west. North of west means like that, right? This is what velocity of wind, right? Now we need to find the direction in which a flag on the flagpole flutters due to this wind. See, because of this wind, as wind is blowing like that, see, this is the direction of wind, right? This is the direction of wind. So due to wind flows here, a flag which is mounted on a flagpole flutters due to this wind, right? We need to find the direction of flag which flutters, right? Now see, this is what Vs, 30 kmph. This is what VW. What is the VW? That is wind velocity of wind, that is 15 kmph, right? See here, what is the direction which flag flutters means the velocity of wind with respect to ship, right? See, this is what velocity of ship with respect to ground. This is what velocity of wind with respect to ground. But a flag which is fixed to a flagpole, that must flutters in a direction in which velocity of wind blows with respect to ship, right? Now, what is the velocity of wind with respect to ship means that is VW bar minus V ship. VW means V wind. Vs means velocity of ship. Right? Again, I am writing VW bar plus or minus Vs bar. In simply, VW bar minus Vs bar in the sense add minus V bar to VW. Add minus V bar minus Vs bar to VW bar. Right? Simply make it reverse Vs. Make it reverse Vs and add to VW. See, this is what VW. This is what Vs. Just make it reverse Vs. See, this is the actual direction of velocity of ship. Simply make it reverse like that. So this is what minus Vs bar. Minus Vs bar. Now what is the velocity? What is the angle made by velocity of wind with the equator means that is 60 degrees. See, this is what 60 degrees. 60 degrees. Right? 60 degrees. 60 degrees. Right? Okay. 60 degrees. Now see, these two are parent vectors, VW and minus Vs bar. VW and minus Vs bar are parent vectors which are drawn from common point. If I take these two as adjacent sides of parallelogram, see, parallel to this side, I am taking this side parallel to VW, right? Right? Now I am taking one more side here to close the parallelogram, parallel to minus Vs bar. Parallel to minus Vs bar, right? Like that. Parallel to minus Vs bar. Okay, like that. Okay, now see, this is parallel to minus Vs bar, this is parallel to VW bar. Now if I take these two as adjacent sides of parallelogram drawn from the same point, right? To have parallelogram, closed parallelogram. Now a diagonal drawn from the same common point is the resultant of these two. Now where is the resultant here? This is the result. This is the resultant, right? This is what is the resultant here? VWS bar, that is VW bar plus or minus Vs bar. Means addition of minus Vs bar and VW bar. See, this is what VW bar, this is what minus Vs bar. On adding these two, making use of parallelogram. Definitely, diagonal from the same common point is the resultant. That is, resultant is VWS. VWS bar means relative velocity of wind with respect to ship. VWS means relative velocity of wind with respect to ship. Now see, these two parent vectors. So this is what theta. In fact, this is what theta. Theta equal to 60 degrees. Now this is what resultant, which makes an angle alpha with one of the parent vectors minus Vs bar. Alright? Alpha. Now if I close this side, see, if I close this side like that, extend this side also, to have right angle triangle here. See, to have right angle triangle. Now, see, this is what right angle triangle. In this triangle, tan alpha. See this right angle triangle. Tan alpha equal opposite side by adjacent side. Now, from here to there, what is the measurement here? Minus vector is minus Vs bar. From here to there, what is the vector? Minus Vs bar. And measurement is Vs. Take modulus of minus Vs bar, means this side is Vs. Now, if it is 60 degrees, this angle also 60 degrees. 60 degrees. 60 degrees, right? Right? Now, what is this measurement? If this is VW, this side also VW. Now, here angle is 60 degrees. So, therefore, here this measurement is nothing but if this is VW, this is also VW. This is 60 degrees. Now, what is this adjacent side means? VW cos 60. VW cos 60. Right? This is what the parallel side. Parallel. This is what V parallel here. Now, what is V perpendicular here? See, this is what perpendicular. Right? See, from this right angle triangle, we know this measurement, that is Vs. This measurement is Vs. Now this measurement is VW cos 60. Why? Because if this is VW, this is also VW. Now what is this adjacent side means in this right angle triangle? That is what? VW cos 60. Now what is this opposite side? VW sin 60. So opposite side, perpendicular side, opposite side is VW sin 60. If this is VW, this is also VW, but this is VW sin 60. So VW sin 60, right? Now, if I take tan alpha from this right angle triangle, tan alpha equal opposite side by adjacent side. So tan alpha equal to opposite side by adjacent side. What is opposite side? That is VW sin 60. VW sin 60 divided by, right? Divided by, see, this is the adjacent side. In this right angle triangle, this is what adjacent side. What is adjacent side? From here to there, Vs. From here to there, VW cos 60. That is Vs plus VW cos 60. Right? Okay. Right? So tan alpha equal to this one by this one. This one by this one. Now see, tan alpha equal to VW means, what is VW? 16. Sorry, 15. 15 into sin 60 root 3 by 2 divided by Vs means what? 30. 30 plus again VW means what? 15 into cos 60 means 1 by 2. 1 by 2. Right? That is 2 into 30, 60 plus 15, 75. 75 by 2. By 2 is there. Take LCM here, 2 into 30, 60 plus 15, 75 by 2. Here numerator 15 into root 3 by 2. So 2 cancel here, right? 15 by 75 means 1 by 5. Root 3 by 5. That is what? Tan alpha equal to root 3 by 5, right? Here alpha equal to tan inverse of root 3 by 5. So this is the direction. Here let us see one interesting numerical here. Say between two stations X and Y on a straight road, constantly buses are departing from Y to X or and X to Y at uniform speed every t minutes. Right? A cyclist riding from X to Y at 10 km/h every 18 minutes, a bus overtakes him in his direction of motion and crosses him every 6 minutes in opposite direction. Find the speed of buses and time between departure of two buses. See here, we have two bus stations. Suppose here Pandit Nehru bus station in Vijayawada, X, let it be X. Here Tenali bus station, Y. So here two stations are there, bus stations. Here buses are running either from X to Y or Y to X at regular time intervals with constant speeds. Right? From X to Y or Y to X. Right? So buses are running at constant speed at regular time intervals. Right? But here one cyclist left from station X and riding towards station Y at constant speed 10 km. Here the data is a cyclist riding from X to Y at 10 km/h. In every 18 minutes, one bus overtakes him in his direction of motion. See, in his direction of motion, in every 18 minutes, one bus overtakes him. But in opposite direction, in every 6 minutes, one bus crossing him. Right? So in his direction of motion, in every 18 minutes, one bus overtakes him. In opposite direction, in every 6 minutes, one bus crossing him. Right? Now, making use of that data, we need to find the speed of buses and the time interval between two successive buses. Right? So here, so many buses are departing from both station X and station Y. Right? In between, cyclist is riding from X to Y. He is noticing that some buses are overtaking him and some buses are crossing him opposite direction. Right? Now see, the successive, what is the time interval between successive buses here? Constant, that is t. Right? In his direction motion, otherwise in opposite direction. In both cases, see here one bus, here one more bus, here also two buses. So one by one, departing from x and y, right? But what is the constant separation between successive buses? Yes, it is constant. Why? Because speeds are constant. Here, time interval between successive buses are also constant. That is what T. So separation S, time interval T. Here also separation between buses S and time interval T. Right? Now here we can write it as S equal to Vt. S equal to speed of bus into time interval. S equal to Vt, number 1. So with respect to cyclist, same can be written as with respect to cyclist. With respect to cyclist, we can write as follows. So T equal to, in its direction of motion, T equal to distance by relative speed. What is the relative speed in its direction of motion? That is V minus 10. V minus 10. See, both are in the same direction. Here V, rightwards. Velocity of cyclist also rightwards. What is the relative velocity? That is V minus 10. Relative velocity of bus with respect to cyclist. So, time equal to separation or distance between successive buses by relative velocity. What is that relative velocity? V minus 10. Right? V minus 10. So, in opposite direction, same can be written as T equal to separation S by relative velocity of bus with respect to person, cyclist. Now, what is the relative velocity of bus here? V minus of minus 10. Why? Because V is leftwards. Here 10 km/h is rightwards. What is the relative velocity? V minus of minus V 10. That is V plus 10. V plus 10. Right? So, here T1, here T2. Here T1, here T2. What is the time interval in overtaking in this direction of motion means? That is 18 minutes. So T1 means 18 minutes. Here T2 means opposite direction. T2 means 6 minutes. So same can be written as T1 means that is 18 minutes. 18 minute. If it is converted into hours, 1 minute equal to 1 by 60 hour. That is 18 minute means 18 into 1 by 60 hour. So converted into hours. So 18 minutes means 18 into 1 by 60. That is equal to S by V minus 10. Right? So number 2. Similarly here T2 means, what is T2 here? 6 minutes. Right? In every 6 minutes buses in opposite direction cross the him. So 6 minutes, 6 into minute means 1 by 60 hour. That is equal to S by V plus 10. Right? S by V plus 10. Right? So implies S equal to, same can be written as, otherwise V minus 10 equal to 60 S by 18. 60 S by 18. Here V plus 10 equal to, V, take cross multiplication here, V plus 10 equal to 60 by 6 into S. It is 60 by 6 into S. Right? Now I am taking this is what 3, 4, this is what 5. This is what 5. 4 and 5. On adding 4 and 5, we can eliminate, see, plus 10 minus 10. Cancel each other. 4 plus 5 implies that 4 plus 5. On adding 4 and 5, here V minus 10, V plus 10. V minus 10, here V plus 10. 60 S by 18 here, 60 S by 6 here. Alright? On adding, minus 10 plus 10 cancel here. V plus V, 2V becomes equal to 60 S by 18 plus 60 S by 6. That is what 60 S by 18. 60 S by 18 plus here what 10 S. That is 2V equal to, take LCM 18. So 18 into 10, 180 plus 60. 240 S. 240 S. Right? That is implies V equal to, I am cutting with 2, that is V equal to 120 s by 80. 120 s by 80. That is, on simplification, what will you get here? 20 by 3s. V equal 20 by 3s. V equal to 20 by 3s. Right? V equal 20 by 3s. Now, suppose here 5 implies. If I take like that, 5 implies. Replace here. 5 implies 5 plus V plus 10 equal to 60 by 6 means 10. 10 into S. S means what here? S equal to 3 by 20V from this relation. This is what number 6. So 6 implies S equal to, what is S here? 3 by 20V, right? So substitute this one. So V plus 10 equal to 60 by 6 means 10. S 10 into S means here what? 3 by 20V. 3 by 20V, right? So that is what 5 implies. You can write it as V plus 10 equal to 10 into S. S means 3 by 20, right? That is 0, 0 cancel here. That is, carry this V on to RHS, that is 10 equal to 3V by 2 minus V. That is 3 by 2V minus V means 3 by 2 minus 1. That is 1 by 2V. So 1 by 2V. So V is equal to 20. 2 into 10. 20 kmph. This is what V means what? Speed of bus. It's 20 kmph. So every bus departing from station with a constant speed 20 kmph. So either in his direction, otherwise in opposite direction. Right? So this is what speed of bus. Now we need to find time interval between successive buses. Time interval. Where shall we substitute here? V equal to, we have V value and S value, right? Now here, see, in previous case, S equal to V into T. We know that what is S? S equal to V into T. So 1 implies here, first expression is there, 1 implies S equal to V into T. Now V means 20, S means what? 3 by 20. S means 3 by 20 V, that equal to V into T. V cancel here. That is T equal to 3 by 20. What is 3 by 20? Hour. That is T equal to 3 by 20 hour. That equal to 3 by 20 into 1 hour means 60 minutes. 60 minute. Right? 1 hour equals 60 minutes. That is 23 jar. So 3 3 jar 9. So T equal to 9 minutes. 9 minutes. So this is what the time interval between successive buses, either from X to Y, otherwise Y to X. Okay. Let us see one important numerical. What is that? To find shortest distance or closest distance of approach. Right? Now see here, two ships A and B are 10 km apart on a line running south to north. Ship A farther north is streaming west at 20 kmph and ship B is streaming north at 20 kmph. What is their distance of closest approach? And how long do they take to reach it? Right? Now here we need to find the closest distance between two ships. So in case of closest distance of approach, now here two steps involved. What are the steps here means? See, step 1. One of the two bodies assumed to be stationary. Suppose in case of two bodies which are under motion, and you need to find, if you need to find the closest distance of approach, in that case one of the two bodies is assumed to be stationary, right? So step 1, one of two bodies assumed to be stationary, assumed to be at rest. At rest means stationary, right? Now step 2, What is step 2? Means find the relative velocity of other body with respect to body which is assumed to be stationary. Find relative velocity of other body with respect to body assumed at rest. Right? So find the relative velocity of other body with respect to body which is assumed at rest. Right? Now, step 3. What is the step 3 involved here? Step 3, that is, now a normal distance from body assumed to be at rest onto relative velocity is the shortest distance. That's all. So a normal distance between body assumed at rest and line of relative velocity. A normal distance between body assumed at rest and line of relative velocity is shortest distance. Is the distance of closest approach. The distance of closest approach. See, the distance of closest approach. See here, whenever you want to find the distance of closest approach in case of two bodies which are under motion, we have to follow these steps. So one of the two bodies assumed to be at rest, and second step, we need to find relative velocity of other body with respect to body which is assumed at rest. Now step 3, a normal distance between body which is assumed at rest and the line of relative velocity is the distance of closest approach. Am I right? Now see, here two ships A and B are 10 km apart on a line running south to north. Right? Now see, this is what north, south, east, west. These are the directions, general direction, north, south, east, west. Now see, two ships A and B are 10 km apart on a line running south to north. Running south to north means this is the line. So on that line, two ships A and B are 10 km apart. Right? Between those, ship A farther north is streaming west at 20 km/h. Right here, see, this is what origin O. So this is what farther north here, somewhere here farther north. Ship A is there at farther north on the same line, north-south line. Right? So ship A is at farther north and is streaming west at 20 km/h. 20 km. See, streaming west at 20 km/h. So VA, that is 20 km/h. Right? Now, where is the other ship, that is ship B, is streaming north at 20 km/h. It is not at farther north, but north means from origin, ship B is running like that on the same line. So this is what VB. This is what VB. VB also 20 km/h. Right? So ship A and B are lying on the same line. That is, what is that line? That line is running south to north. See, south to north. Both are on the same line, but A is at farther north and streaming at 20 km/h west, and B is at 20 km/h north. Right? So these are the velocities for ship A and ship B. See, ship A is due north and ship B is due north and ship A is due west at farther north. Right? Now, what is the question? What is the distance of closest approach? Distance of closest approach. Right? So now itself I said that if you want to get the closest distance between those two, now first step is one of the two bodies assumed to be at rest. What is the first step here? One of the two bodies assumed to be at rest. See, either B or A assumed to be at rest. Right? I am taking that A is at rest. So say A is at rest. VA is 0. First step is over. I assumed that A is at rest. Right? Now what is the second step here? Find the relative velocity of other body, means B. Other body means B. So we need to find relative velocity of other body B with respect to body which is assumed at rest, means VBA. So we need to find VBA. So VBA question mark. VBA question mark, right? Now VBA question mark. Now what is VBA? VBA means VBA equal to VB bar minus VA bar. That is equal to VB bar plus or minus VA bar, right? Means adding minus VA bar to VB bar. That's all. So this is also one kind of addition. Means simply make it reverse VA bar. See, this is what VA bar. Simply make it reverse VA bar onto that side and add with VB. That's you will get VBA, relative velocity B with respect to A, right? See, this is what VB that is 20 kmph. Now this is what VA. Simply make it reverse. Means like that. That is minus VA minus VA also 20. If I take somewhere here, you will get triangle. If I take somewhere here, you will get parallel, right? This is what minus VA bar. Minus VA bar also 20 kmph. If I join somewhere here, you will get triangle. If I join somewhere here, you will get parallel. Both one and the same. See, VB bar and minus VA bar are joined coinitial and taken as the adjacent sides of parallel, right? Now the diagonal drawn from the same point is the resultant. That is what VBA, right? Now I am trying to close parallel. So parallel to this side, I am taking somewhere here one more side, right? Parallel to this side, I am taking somewhere here one more side. Means parallelogram is constructed. Now diagonal drawn from the same point is the resultant. See, this is what resultant. What is this? VBA bar. That is VBA. Right? VBA. What is VBA? See, root over 20 square plus 20 square. Why? Because these two are perpendicular to each other. Parent vectors are perpendicular to each other. Moreover, of same magnitude. Same magnitude means 20, 20. Now, what is the hypotenuse? Root over 20 square plus 20 square. That is root over 20 square plus 20 square. Right? That is root to 20 kmph. 20 root 2. Otherwise, 2 root 20 root 2. 20 root 2 kmph. So this is what relative velocity with respect to ship A. Right? Okay. Now, so step 1 over, step 2 also over. Step 1. Between A and B, I took A is at rest. Of course, this is also under motion with respect to ground, but for the time being, I am taking that A is stationary, A is at rest. So, second step, relative velocity, I need to find relative velocity of B with respect to A. See, this is what relative velocity B with respect to A also. What is the direction of relative velocity B with respect to A means? See, these two are of same magnitude, resultant bisects. Means this is 45 degrees, this is also 45 degrees. Right? Why? Because parent vectors are of same magnitude, resultant bisects. Right? So, thus that these two angles are equal. What is the net angle here? 90. So, divides 45, 45. That's right. So, second step over. Now, what is the third step? What is the third step? We need to find the distance of closest approach. How to assign the distance of closest approach means, see here, a normal distance between body assumed at rest. See, A is assumed at rest. A is assumed at rest, right? Somewhere here A, in fact, somewhere here, this is what A, this is what B, right? So, a normal distance, see, this is what A, right? This is what its vector, velocity vector on reversing, right? In fact, this is A. Now, what is the distance between them in terms of distance? This is what 10 kilometers from data. Distance between A and B is 10 km, see, 10 km, right? This is what velocity of B, but separation is 10 km, right? Now, a normal distance between body assumed at rest and a line of relative velocity. This is what line of relative velocity. Line of relative velocity of other body B with respect to previous body, that is which is assumed at rest. So VBA, this is what line of VBA. Now this is what body assumed at rest. So a normal distance from body assumed at rest to line of relative velocity is the shortest distance. Shortest distance x. For example, this is what x, right? So these are the steps. Now I'm going to find x value. I'm going to find x value, right? How to get x? See, we know this angle. We know this separation also. What is the separation here from A and B? Between A and B, that is 10 km, right? See, I'm rewriting somewhere here. This is what in terms of distance 10 kilometer. This is what A. This is what B, right? This is what VBA 20 root 2, right? So this is what the closest, the distance of closest approach, right? Distance of closest approach, x. So this angle is 45 degrees. So sine 45, opposite side by hypotenuse, right? So sine 45 equal to opposite side by hypotenuse, 10 k. 1 by root 2 equal to x by 10. X equal to 10 by root 2. I am multiplying and dividing with root 2. That is root 2 by root 2. So root into root 2 means 2. 10 by 2 means 5. 5 root 2. So x equal to 5 root 2 kilometers. So this is what closest approach. Closest approach between A and B. Right? Closest approach between A and B. So closest distance is over. Now we need to find the time. How long do they take to reach it? So what is the time taken by them such that to have closest approach between them, right? Now time taken. See this velocity. What is the velocity in this direction? That is 20 root 2, right? We know relative velocity along this way, right? We know this side also. Now what about this side here? If I take sine tan 45, that is x by this one. So tan 45 equal to if I take, suppose I am labeling here d as d, right? That is tan 45 equal to x by bd, tan 45 means 1. So implies tan 45 1 implies bd also equal to x. So in terms of distance, bd also same. What is the distance? bd equal x, that is 5 root 2. So we are familiar with bd and relative velocity. Now time taken equal to, if I take velocity this way, VBA, so I have to substitute the distance bd, right? So why? Because I am familiar with VBA along this way, right? VBA. What is that? The value 20 root 2 kmph. Now if I take distance from B to D along this way, easily find, we can find time. Time equal to distance by BD by VBA, right? That is BD means what? Of course BD equal x also in this case. Why? Because angle is 45 and 45 means these two are same sides, right? So BD means 5 root 2 divided by VBA means 20 root 2. So 20 root 2 cancel. 5 by 20 means 1/4 hour. 1/4 hour means 15 minutes. That is 15 minutes. So within 15 minutes they have closest approach, right? They have closest distance of approach. So what are the steps involved in case of to find closest distance of approach? Means one of the two moving objects is assumed to be stationary. Now step 2. What is the step 2? We have to find relative velocity of other body with respect to body which is assumed stationary. And step 3, how to assign the closest distance of closest approach means a normal distance from body which is assumed to be stationary onto line of action of relative velocity of other body with respect to which is a body which is assumed to be stationary, right? Okay. Finally, one more numerical, most important numerical. See, take a look here. Aeroplanes A and B are flying with constant velocity in the same vertical plane at 30 degrees and 60 degrees. See, with respect to horizontal. This is what horizontal. With respect to horizontal, two planes A and B are flying at 30 degrees and 60 degrees respectively as shown. Now, what is the velocity of plane A? That is 100 root 3 meter per second. The speed of A is 100 root 3 meter per second. At time t equal 0 seconds, an observer in A finds B at a distance of 500 meter. The observer sees B moving with constant velocity perpendicular to the line of motion of A. See, one passenger from A observes as if B moves on a perpendicular line with respect to plane A and is at a distance of 500 meters on a perpendicular line, right? That's what observed by one passenger in plane A. Now, what is the question here? If at t equal t naught, A just escapes being hit by B, right? At a time t naught, at some time t equal t naught, A just being escaped from being hit by B, right? So, what is the time taken? What is the t naught here in seconds? That is what we need to find. Now, see, both A and B are flying at 30 degrees and 60 degrees from horizontal. But one passenger from A observes as if B is at a distance of 500 meters and is moving towards A on a perpendicular line. Okay. But at t equal t naught, plane A just escapes being hit by B. Now, what is that t naught in seconds? That is unknown. Now, I am rewriting like that. See, this is what plane A. What is the velocity of plane A? VA, that is 100 root 3 meter per second. Right? So here, what is the angle made by direction of motion of A with respect to horizontal means 30 degrees. Right? Here, one more plane B is there now. Now, what is the direction of motion of B? Making 60 degrees with horizontal. Making 60 degrees with the horizontal. Say this is what? 60 degrees. This is what direction of motion of? This is what direction of motion of B. VB. Right? What is the angle made by VB with horizontal? See, this is what horizontal. Angle made by VB with horizontal is 60 degrees. 60 degrees. Right? Now, passenger in plane A finds as if plane B is moving along perpendicular line. Now, passenger from A observes B means velocity of B with respect to plane A. Otherwise, passenger in plane A, whatever it is. That is VBA bar equal to VB bar minus VA bar. That is VB bar plus or minus VA bar. Correct? So, one passenger from plane A observes as if B moving on a perpendicular line like that. Now, see, that is velocity of B with respect to plane A or velocity of B with respect to one passenger in plane A, whatever it is. That is VB bar plus or minus VA bar. Now, make it reverse VA and add to VB. That's all. So, this is what VA. Just make it reverse. Make it reverse here like that. Parallel to this line. I am writing somewhere here. Okay. So, this is what? Minus VA bar. Minus VA bar. See, VA is just to make it reversed here and joined with tail of VB. Now these two are drawn from the same point and are taken as the adjacent sides of parallelogram. Right? Now where is the parallelogram means we have to write those two sides also, remaining two sides. But here VBA, the direction of VBA is normal to this line of motion of VA. from data. So this is what VBA bar. Why? Because with respect to the passenger from plane A finds that VB is heading towards VA, heading towards plane A on a perpendicular line. So this is what velocity be with respect to A, right? Now try to close other two sides here. So say this is VB, this is 60 degrees, right? Now VBA. What is the separation between these two? Means 500 meters. In terms of distance, the normal distance between plane B and plane A, that is 500 meters also. 500 meters, right? Okay. Now plane, what is the angle made by plane A with horizontal means 30. Angle made by plane B with horizontal means, see, this is what horizontal. With respect to horizontal, angle made by direction motion of B is 60 degrees. 60 degrees. Now I am taking this line. This is what in fact VA. Why? Because these two parallel, right? These two parallel lines, right? So with respect to horizontal, see, this is what VA. So this angle must be 30 degrees, right? So these two lines parallel to each other, So therefore, these two lines parallel to each other like that. So these two lines parallel to each other, angle made by direction of motion of A with respect to horizontal 30. So this is what direction of motion of A with respect to horizontal 30. So total angle 60. If it is 30, this one also 30 degrees. 30 degrees, right? Okay. So here 30 degrees, total 60 degrees. Okay? Right? Now see, passenger in plane A finds as a B heading on this perpendicular line with respect to A. Means there is no displacement covered by B with respect to A along this direction, right? Along this direction, the displacement or distance covered by B with respect to A is 0 along this direction. Why? Because with respect to A, plane B appears to move along this perpendicular line. Sorry, this is the perpendicular line. In fact, this is the perpendicular line, right? So this is what VBA. So this is what VA, right? VBA. This is what VBA. Okay. VBA bar. Now distance between these two, that is 500 meter. 500 meter. Okay. Now with respect to person in plane A, what is the relative separation along this way means 0. Why? Because along this way, S relative equal to this what, if it is VB, this what VB cos 30. Am I right? So this is what VB cos 30, VB sin 30, right? So this is what VB cos 30, this is what minus VA. So S relative equal to V relative into tan. So along this way, that is parallel to direction of motion of A. Along this way, so there is no displacement covered by B with respect to A. Therefore, along this way, if I find S relative equal to V relative into T, so S relative 0, that equal to, why? Because along this way parallel to A. That is S relative equal to V relative means V cos 30 minus VA. So V cos 30 minus VA into T, right? So T never be 0. Therefore, V cos 30 minus VA equal to, VB cos 30. So VB cos 30 minus VA must be equal to 0, right? That is VB cos 30 equal to VA. So VB cos 30 means root 3 by 2 ఇప్పుడు VA means what is VA? 100 root 3. 100 root 3. So root 3 cancel. VB equal to 200. 100 into 2, that is 200 meter per second. So that is what velocity of player B, right? 200 meter per second with respect to ground. So why it is taken like that means here with respect to A, there is no displacement covered by B parallel to A. So in this direction, relative displacement covered by B is 0. That is 0 equal to VB cos 30 minus VA into T. So VB equal to 200 meter per second. Right? Now the question is, in a time T naught, plane A just escaped being hit by B. So being hit by B means with respect to passenger in plane A, this plane B appears to move along perpendicular line. Okay, so just escaped from hitting means the relative separation 500 is cleared here, almost cleared. So this relative separation equal to how to find? So S equal to now what is the velocity here? Velocity into time. So S means S, that is 500. Velocity means what here? See, VB cos 30, here VB sin 30. Perpendicular component for VB. Here parallel component is VB cos 30, here perpendicular component is VB sin 30. But VA doesn't find any components. Why? Because this is the perpendicular line with respect to VR with respect to minus VA. So therefore VA, this is what perpendicular line with respect to VA. So this is what the component of VA along this way 0. The component of minus VA along this way also 0. So we have only component for VB along this way. Therefore, what is the component of velocity along this way to cover 500 meter means VB sin 30. So this is what VB cos 30, this is what VB sin 30. So VB sin 30 into time. So S means what? 500 meters. And VB means 200. The sin 30 means 1 by 2 into T. T means here T naught. T becomes T naught. So 2 zeros, 2 zeros. 2 cancel. So T naught equal to 5 seconds. So within 5 seconds, this normal distance 500 meter is covered by B with respect to A along perpendicular line and just being escaped by being hit by B. Just escaped being hit by B. Okay. So what is the time means 500 seconds. So this is the time taken by B to cover normal distance of 500 meter with respect to A. Okay friends, with this I conclude. So in next video we discuss most important concept, that is rain umbrella problems. So please stay tuned to sea level physics. Have a nice day. Thank you.